this lecture of the vector calculus. Today I will solve miscellaneous problem based on curl, divergence and grad. So let us start with my problem. Here we have to show that the vector field f equal to x square minus y square plus x into I minus 2xy plus y into j is irrotational. So that this vector field is irrotational, and if it is irrotational, then find the scalar point function and hence find the scalar function phi such that f equal to grad phi. So if your f is irrotational, then we have to find out f equal to grad phi. Now again also evaluate the line integral 1 from 1, 2 to 2, 1. So again evaluate this line integral. So solution, first of all we will show that our curl of f is equal to 0. So your f is equal to x square minus y square plus x of I minus 2xy plus y of j, then we can write it as 0 into k. So your curl of f will be equal to I, then we have j, then we have k, del by del x, del by del y, and del by del z of x square minus y square plus x minus 2xy minus y, then we have 0. So this is equal to I into 0 minus 0. So this is your first component. Then we will have for the j, again we have 0 minus 0. Then for k, we have del by del x of this one, which is your minus 2y, and del by del y of this one is minus 2y. So this is equal to minus 2y, then we will have minus sign, del by del y of this one, then this will be your plus 2y. So you can see that this is equal to 0. So your curl of f equal to 0. Now we will find a function phi for which f is grad phi. So from here our curl of f is equal to 0. As we know that curl of grad phi is equal to 0, so that means we can write f equal to grad phi. So we can write f equal to grad phi. Now let us find out this phi. So let us find out this phi. Now your f dot dr, I have already given you the value of f dot dr equal to d phi in my previous lecture. So as this f dot dr is equal to d phi, and if you want to prove this one, and you can easily prove it. So this will be your d phi dot del phi dot dr. Your del phi means I del phi upon del x plus j del phi upon del y plus k del phi upon del z into dr. Dr means your dxi plus dyj plus dzk. So you can see that I dot I is 1. So this is your basically del phi upon del x into dx, del phi upon del y into dy, del phi upon del z into dz, and this can be written as your d of phi with the help of the definition of the total derivative. So this is your d phi. So we have the value of d phi. So therefore your d phi equal to f dot dr, and it is true whenever your vector f is grad phi. Okay, Now let us integrate this equation. So for that, just put the value of f. So your f is equal to x square minus y square plus x I. Then we have minus 2xy minus yj, and then our dr will be dxi plus dyj. So your d phi equal to this thing, and as your I dot I is 1, so we have x square minus y square plus x dx. Then we have minus 2xy minus y dy. So this is the value of d phi, and we can write it as, just write it as x square plus x dx, and then here we will have minus y dy. Then this term, that means your y square dx and 2xy dy can be written together. Now the integration of x square will be x cube upon 3, and the integration of x will be x square upon 2. Integration of y will be y square upon 2, and then we can, okay, before that let us merge these two terms. So here we can write it as x square dx minus y dy, and this bracket can be written as d of y square x, because if you differentiate with respect to x, then we will get y square dx. Now the differentiation with respect to y will give you 2y into x, and then differentiation of y will be dy. Now integrate this whole equation. So on integration we get phi equal to integration of x square will be x cube upon 3, integration of x will be x square upon 2, integration of y will be y square upon 2, and then the integration of this will be y square x, and then we will have some constant of integration. So this is what we have to get. So this is your phi, which is equal to integration of x square x cube by 3, integration of x will be x square by 2, then we have minus y square by 2, and then the integration of y square x will be differentiation, this d will get removed, so we have minus, so here we have minus sign. So this minus y square x plus some constant of integration. Now we have to evaluate the line integral from passing through 1, 2 to 2, 1. So your line integral will be is equal to the value over the curve C into f dot dr. Now your f dot dr is your d phi. So if you write 2 points on the curve as 1, 2, 2, 1, then this will be your equal to phi of phi at 2, 1 and the value of phi at 1, 2. So this will be your answer. Now just simplify this one. So if you put x equal to 2, then we will have 8 upon 3. Then we will get, put the value of x as 2, so we will get 2. Then y is half, your y is 1, so we have half. Then we will have minus 2. So this will be your 8 by 3 minus half. So this will be equal to 13 upon 6. The first part is 13 upon 6 plus some constant of integration. Now for the second part, put x equal to 1. Then this will be 1 by 3 plus 1 by 2, that means 5 by 6. And then we will have, put y equal to 2. So this will be a minus 2. Put y equal to 2. So this will be 4. So that means 6. So this will be a minus 31 upon 6. So we have minus 31 upon 6 plus some constant of integration. So this is equal to 13 upon 6 plus 31 upon 6. So that means this is your 44 upon 6, and which is same as 22.3. So the value of line integral is equal to this 22.3. But we can evaluate this line integral only when your field is conservative. That means when your curl of f is equal to 0. Then our next question is, again our next question is to show that it is similar to this question. Here we have to show that this vector field A equal to x square plus xy square I plus y square plus x square y j is irrational, and further we have to find out this phi. So again, so that this is your irrational and find your phi. So your solution will be, just calculate your grad A, curl A. So solution curl A will be equal to I j k del by del x del by del y and then del by del z, and the component of A are x square plus xy square, y square plus x square y, and then 0. And you can see that this is again equal to 0. So this will be your 2xy, then there will be again minus 2xy, again it is 0. So your curl A is equal to 0. Now if your curl A is 0, then as in my previous question, your A will be equal to grad phi. So let us evaluate this phi. Again, as in my previous problem, your d phi is equal to A dot dr. We know that d phi is equal to A dot dr. So your A is equal to, so put the value of A and it is equal to, so therefore your d phi is equal to A is your x square plus xy square, then we have y square plus yx square j, and then dr. dr is dxi plus dyj. So this is equal to x square plus xy square dx plus y square plus yx square into dy. Now this can be written as x square dx plus y square dy. Then we can write it as x y square dx, then yx square dy. Okay. So now let us integrate this term. So on integration, we get the integration of d phi will be phi, integration of x square will be x cube over 3. Now before that, let us write this as, now what is this? This is equal to, now we can write it as, okay, we can write it as like this, x square y square, because the differentiation of x square will be 2x and then the differentiation of x will be dx. So in the numerator we will get 2, and again here then take this y square as fixed. Now we will take x square as fixed, then the differentiation of y square will be 2y, and then the differentiation of y will be dy. So on integration we get phi equal to x cube upon 3 plus y cube upon 3 plus half x square y square plus some constant of integration. So this is your solution of this problem. Then again show that one more question of this type. Show that your r cube, okay, before that, now let us show that now we will put that, now let us show that question, show that your divergence of grad r power n is equal to del square r power n is equal to n into n plus 1 into r power n minus 2. So let us prove this result. Divergence of grad r power n equal to this divergence of grad phi. We have already evaluated the formula for divergence grad phi, but here let us prove that this is equal to this n into n plus 1 into r power n minus 2. So solution. So before that, let us evaluate the grad of r power n. So grad r power n means del r power n. So del r power n will be equal to summation I del by del x of r power n, and this is equal to I. Now the differentiation of r power n will be n into r power n minus 1 into del r upon del x. Your del r upon del x is equal to x upon r, because we have this condition r square equal to x square plus y square plus z square. So now this is equal to n into r power n minus 2 into summation I x, and your summation I x is vector r. So this is equal to n into r power n minus 2 into vector r. So therefore your grad r power n is equal to n into r power n minus 2 into vector r. So this is our grad r power n. Now let us find out its divergence. So divergence of grad r power n is equal to I dot del by del x of this bracket n into r power n minus 2 into vector r. Now we can take this n outside, so we have I dot, now the differentiation of this bracket, differentiation of r power n minus 2 will be n minus 2 into r power n minus 3 into del r upon del x. Then we will have vector r, then n into r power n minus 2 into the differentiation of del r upon del x. If you want to apply the formula, then you can also apply the formula for divergence of this bracket, and this is your scalar, so we can use the formula for divergence of UV, and your divergence of UV is equal to grad u dot b plus u divergence b, and then you can also get the value of this divergence grad r power n with the help of that formula. But here I am going to calculate it. So this is equal to, now for the okay, so this is equal to plus summation I dot this term. Okay, now the first term will be, then there is no need to take this bracket, so this is equal to n. Now your del r upon del x is x upon r, so we can write it as, take this n minus 2 outside, so in the bracket we will have I dot r power n minus 3 your x upon r into vector r. Then here we will have n, again your del r upon del x is vector I, so the bracket will give you I dot I. This vector del r upon del x is vector I, whereas the scalar del r upon del x is x upon r. So this is equal to, now this will be your r power n minus 4, and that can be taken outside, so we have n into n minus 2, then outside we will have r power n minus 4. Now this I and x can be taken together, so we have summation I x dot vector r, and again here we have summation I dot I, so we have 3 and r power n minus 2. So this is equal to, now your I x will be, summation I x will be vector r, so this is your r dot r, so your r dot r is r square, so this is equal to n into n minus 2, then your r dot r is r square, so this is your r power n minus 2, and again we have 3 and r power n minus 2. So this is equal to, take this r power n minus 2 common and take n common, then in the bracket we will have n minus 2 plus 3, so this is equal to n into n plus 1 into r power n minus 2. So therefore your divergence of grad r power n is equal to n into n plus 1 r power n minus 2. We can also use this one as a formula for many problems. So now with the help of this formula, we can say that we can put our next question, show that our next question is show that our r, so that the vector r power n into vector r is irrotational for all n but solenoidal if only if n equal to minus 3. So solution. Here we have to show that this vector r power n into vector r is irrotational, that means its curl is 0 for all n, but it is solenoidal if and only if your n is equal to minus 3. So let us find out the divergence of r power n into r. So for that we need grad r power n. Now we have the formula for grad r power n here. This is your grad r power n, so I am not going to evaluate this one. We just take this as a, we will treat this as a formula. So because your grad r to power n is equal to n r to power n minus 2 into vector r, in examination you can prove it. So this is your grad r to power n. Now let us take the divergence of this grad r to power n into vector r. Now if you want to apply the formula of divergence u into v, then you take this, then use this formula. Then otherwise you can also evaluate it directly, and then you can show that this is equal to 0 or this is equal to 0 if and only if your n is minus 3. So here I am using the formula of divergence uv. Your divergence of uv is equal to grad u dot v, then u divergence v. I will also prove it directly. Now your grad r power n is equal to n r power n minus 2 into vector r. So we have again vector r here. Then as we know that divergence of r is 3, so this is equal to 3. Now this dot r will be your r square. So this is equal to n into r power n. Then 3 r power n. This is equal to n plus 3 into r to power n. Now you can see that this will be 0 if and only your n equal to minus 3. So this is 0 if only n is equal to minus 3. So your vector r to power n into r will be solenoidal if and only if your n is equal to minus 3. Now we will show that it is irrotational for all the values of n. So for that let us evaluate the curl. Now for curl we have the cross sign here, and here we will take the curl of r. And we know that the curl of r is equal to 0. So as the curl of r is equal to 0, so this term is 0, and again we will get cross sign here. So this is your r cross r, and again r cross r is 0. So we have 0 plus 0, so this is equal to 0. So the curl of r to power n into r is equal to 0. So that means this vector is irrotational for all the values of n, but solenoidal for n equal to minus 3. Then our next question is, then in the next question, now if you put n equal to minus 3, again it will be your irrotational. So let us solve, show that, again show that r to power minus 3 into r is irrotational. Now if this is irrotational, then find the scalar point function phi. Now if this is irrotational, then we have to find out this phi. Now as in my previous problem, this will be irrotational for all the n. So solution. Now here I am not using the any, I am not going to apply any formula. So let us prove that it is equal to 0, its curl equal to 0 with the help of the definition. So here I am not using this formula and this formula, and this method can also be used for this question. So this r power minus 3 into vector r will be, now here I am going to use this definition, and with the help of computation I will show that this is equal to 0. So this is equal to, now the differentiation of r power minus 3 will be minus 3 into r power minus 4 into del r upon del x, which is your x upon r. Then we have vector r, then we have minus r power minus 3, and the vector differentiation, the differentiation of vector r with respect to x will be I. Now this first term will be minus 3 r power minus 5. Now in the bracket we will have summation ix cross r, and for the second term we have r power minus 3, and then the bracket will be your I cross I. Your I cross I is 0, and here we have vector r cross vector r, and here we have vector I cross I. As your vector I cross I and vector r cross r both are 0, so that means this vector is irrotational. So this implies that your r power minus 3 into r is irrotational. Now if this is irrotational, then find the value of, now if it is irrotational, then we will calculate our phi. So let us find out phi. So therefore we can say that, say if this vector is f, then we can say that our f equal to grad phi. Now we will calculate this phi. Now from here we will have d phi equal to f dot dr, as in my previous question. So your d phi is f dot dr, your f is r power minus 3 into r. So this is your vector r upon r power 3 into dr. So this is equal to xi plus yj plus zk upon r cube. R cube means x square plus y square plus z square power 3 by 2 dot dr. Your dr will be dxi plus dyj plus dzk. Now your I dot I will be 1, so this is your x into dx. Then we have y into dy plus z into dz, and then here we will have x square plus y square plus z square power 3 by 2. Now if you take this x square plus y square plus z square as t, then you can see that in the numerator we will have x dx plus y dy plus z dz equal to dt upon 2. So this is your basically equal to 1 by 2 dt upon t power 3 by 2. So if you take this power in the numerator, then on integration we get our phi equal to, now this will be in the power will give you minus 3 by 2, and the integration of this power minus 3 by 2 will give you, the power minus 3 by 2 will give you half upon half. So this will be a minus 3 by 2 plus 1, so we have minus half upon half. So this is equal to half into the power x square plus y square plus z square into minus half upon minus half plus some constant of integration. So your answer is equal to, now this two will get cancelled. Now your x square plus y square plus z square power half is your scalar r, so we can write it as minus 1 upon r plus some constant of integration. So the scalar point function in this case is equal to minus 1 by r plus some constant c. Now next question, show that now in the next question we will do two parts. The first part is show that your vector fr into vector r is again irrotational. and then we will show that our del square of Fr equal to F double dash R plus 2 upon R F dash R. So let us put these two parts. Show proof. Solution. For the first part, let us find out its curl. So curl of Fr into vector R is equal to, again if you want to apply the formula, then you can use the formula for curl of UV, but here I am going to prove this one with the help of the direct computation. So this is equal to Fr vector R, and this is equal to I. The differentiation of R will be F dash R, and then the differentiation of R will be del R upon del X, which is your X upon R. Then again we have F of R, and the differentiation of vector R will be del R upon del X, and del R upon del X is vector I. So the second part will give you I cross I, so that will be 0. And now for the first part, this F dash R upon R will come outside the bracket. Now in the bracket we will have summation Ix cross R, and here we have Fr, and in the bracket we have summation I cross I. So this is equal to F dash R upon R. Your summation Ix is vector R cross R. Then this is your 0. Again this is your 0. So we have curl of Fr into vector R equal to 0. Now the second part. Now for the second part, let us evaluate the Laplace operator of this Fr. So this del square of Fr is equal to, we can write it as summation del 2 upon del x2 of Fr, because we know that the value of del square is equal to del 2 upon del x2 plus del 2 upon del y2 plus del 2 upon del z2. So let us evaluate the first term. Now one time differentiation will give you F dash R, then differentiation of R will be X upon R. Now again let us differentiate this bracket with the help of the product rule. So the differentiation of F dash will be your F dash R, F double dash R, and then the differentiation of R will be del R upon del X, which is your X upon R. Then we will have F dash R. Now the differentiation of X upon R will be, the differentiation of X will give you 1, so we have minus R, then X, and the differentiation of R will be X upon R, then we have R cube. So this is equal to F double dash R, then we will have summation X square upon R square, then here we have F dash R upon R cube. Now in the bracket, this will be of R square, and in the bracket we will have R square minus X square. Now your summation X square will be X square plus Y square plus Z square, which is again your R square, so this will be your F double dash R. Then this is your, then this will be your R square minus X square, next term will be R square minus Y square, and then third term will be your R square minus Z square. So this is equal to F double dash R plus F dash R upon R cube. Now this bracket will be your 3R square, then we have minus X square minus Y square minus Z square, so this is your R square. So this is your 2R square. So this is equal to F double dash R, then we have 2 upon R into F dash R. So this is what we have to prove. So the Laplace operator of F square R, Fr is equal to F double dash R plus 2 upon R into F dash R. Then our next question, then show that the first part is curl R cross A into B is equal to B cross A, where A and B are the scalar vectors, and then the divergence of R cross A into B equal to minus 2 B cross A. So here B dot A. So let us put these two parts, and these are my last questions of this vector calculus. Again, if you want to apply the formula, then you can use this formula for the divergence of B cross W. We have the formula for divergence B cross W, which is your W dot curl B minus B dot curl W. So with the help of formula, you can easily show that this is equal to minus 2 B dot A. And again, we have a formula for curl B cross W. Now here I am not going to apply this formula. Let us prove this is equal to B cross A with the help of the direct computation. So first part, I am just going to prove the first part, and second is the similar to the first part. So this is equal to, here my A and B are the scalar vectors, so there is no need to differentiate them because their differentiation will become 0. So this is equal to I cross del by del x of this bracket R cross A cross B. So this is equal to, now this A and B are constants, so we have just del R upon del x. So we have del R upon del x cross A and then cross B. So this is your I cross, your del R upon del x is I. So we have I cross A cross B. Again now, with the help of the vector triple product, we can write this term as I cross. Now this bracket will be I dot B into A minus, then we will have minus sign, then I dot A, then we will have I A dot B. This is equal to I cross I dot B of A. Now here we will get I cross I. So this second term will become 0. So this second part is 0. Now your I dot B, if you write the vector B as B1I plus B2J plus B3K, then this I dot B is B1. So we can write it as I cross B1 of A, then this is 0. Now this can be written like this, I into B1 cross A. So your I into B1 will be vector B into cross A. So because B is B1I, B2J, B3K. So this is the proof of your first part, and for the second part we will have dot product here. So here we will have dot. So here we will have dot product, and then here we will have I dot I. So this will be 3 times A dot B. So this will be minus 3 times A dot B, and as we have dot product here, so this will be your basically equal to I B1 dot A. So this will be your B dot A, and this will be your minus 3 B dot A. So this will be equal to minus 2 B dot A. So the second part is exactly similar to the first part. So I am not going to prove that. And in the second part we will have I dot I here. So that will be 3. And here we will have dot product. So this will be your B dot A. So B dot A minus 3 B dot A will be minus 2 B dot A. So thank you so much for joining this lecture.